Hello, uh, welcome to the live session of the course Evaluation of Textile Material. I'll be available here for next 1 hour. So if you have any question, you can ask me. So if you have any question, so I have not received any question yet. Can we have question? So I can see that one of the students is waiting there. Can you ask me question? So there was a question which has come online. So what was asked, I want all the testing questions of objective type related to gate practice. So basically all these questions, objective type questions are available online in gate previous year's question. So you can practice on uh, these questions, and also for gate practice, basic thing is that you must go through the textbooks thoroughly. Then obviously you must follow the respective NPTEL courses in detail. You should not miss the questions. And the next question, I think we can see another question was there. In the exam, F table, chi-square table, T table will be provided or not. Definitely the tables will be provided. If not, specific data will be given for which is required to solve the numerical. And I think, do we have any other question? Next. So the transcript uploading, it's not done by me. It's done by IIT Madras NPTEL office, who is actually nodal institute. So if you have any doubt, you can directly contact them. They will do the needful. Okay. Uh, any question? Do you have any question? So you can ask me. I will be available here up to 5 p.m. I would like to clarify all your doubts. Any questions? I can see some of you are watching. You can ask question. So I'm here to resolve your doubts. Either you can ask directly through voicemail, or you can text me. So the through chat I can answer your question. I have not received any new question. So if you have any doubt, you can ask me some question. exam will be in next month after 15 days. So this month end I think. So hope you are preparing well. So if you have any doubt, I am here. Okay, up to 5 p.m. I will be here. You can text me also to chat in detail. I have not received any question after that. I can see some of you are live, but you can ask me any question related to this subject. Any doubt? So you please ask me question if you have any doubt. So basically, if you don't have any question, you think of any question. So what uh, I can now discuss the overall this course pattern and what is its utility. Okay, okay. This course typically it's a undergraduate level course. Typically second year or third year we do this course, and in any textile course, any textile student, this is the core course. That means you have to do this course. It's a basic course, okay? And this course, evaluation of textile material, in some universities it is called textile testing also. So this textile testing part, just we have renamed it as evaluation of textile material. And in this course we cover wide range of testing principles of that is principle of evaluation of fibers material, yarn, fabric, and here we typically deal with the physical testing part. We have not covered the polymer testing, characterization, or any dye related or finishing related testing. This course is all about the physical testing part, Here, the basic requirement of this course is that for any material, whether it's a textile material or any material, we need to evaluate, we need to test the characteristics. So this testing is extremely important, and without testing we cannot certify the characteristics of a product, we cannot select raw material. Even for assessing the performance of any intermediate process, we need to test the material. Like, for example, if we take the textile material as an example here, like fiber length testing. Fiber length testing, first, say cotton fiber length testing, it's extremely important to know the length of cotton, because based on the length characteristics we can select the particular variety of cotton, particular type of cotton for a particular yarn production. As we know, the finer yarn, finer fiber and longer fiber is used for finer yarn count. So in addition to the setting the targeted yarn count, we test the fiber length for performance of machine like blowroom or carding. If we test the fiber length before blowroom and after blowroom, so we can assess the degree of fiber damage. So testing of material is extremely important. So in this course, we have started with the sampling. So sampling means that it's not practically possible to test whole lot due to the fact that it is time consuming, and not also most of the testing are destructive in nature, so that it will destroy the material, and therefore it's very expensive proposition to test whole lot. So to reduce the time required, we use sampling. So detailed sampling techniques have been discussed in that segment, and also sampling techniques of fiber, yarn, fabrics have been discussed. After that, the statistical analysis were discussed, different techniques, and the significance test, and we have also discussed the number of samples required to get certain confidence limit. After doing that, we have then discussed the evaluation of fiber length. That means short fiber we are talking about here. And fiber length testing is normally done for short staple natural fiber, because, and particularly we do test two natural fibers which are important. One is cotton and another is wool. For man-made fiber, we normally don't test fiber length because we have total control over fiber length. So suppose when we cut fiber length of say 38 mm or 44 mm, we know the fiber length and we don't need to measure the length. But on the other hand, the natural product like cotton, the fiber length depends on the type of variety of fiber, and within variety the type of maturity level, type of growth, the fiber length changes. In addition to the fiber length, there is another important characteristics which is fiber length dispersion. So variation in fiber length is also important, and these two parameters, mean fiber length and variability, determines the quality of product. So we test the length parameter as variability, mean fiber length. In addition to cotton, another fiber, natural fiber, which is wool, we need to know the length and variability characteristics. Other fibers, normally we don't measure fiber length. Like if we talk about natural fiber, silk, obviously it's available in the form of filament, continuous form, so we don't need to measure the fiber length. Other bast fiber like flax, jute, in normal condition we don't test the fiber length. There it's a longer fiber, so if we need, we can test fiber manually, fiber length manually. Although the jute fiber, if we talk, it's longer in length, but actual fiber length is very short, which are joined by some gummy material. So there are different types of measurement techniques. Those have been discussed in detail, starting from hand stapling technique, Shardley photoelectric stapler, comb sorter, which is very popular. You must have learned in your BTech course. In the lab also you have done comb sorter. From there, from comb sorter we get large number of information like effective length we can get, we can calculate the dispersion percent, mean length also we can calculate. Obviously, next technique is that single fiber length measurement, and this technique is used for man-made fiber also to understand the level of fiber breakage. Then length measurement by weighing method, that has also been discussed. Clamp taft method is also used, which is based on the again weighing, cutting and weighing technique. And next technique, which is very widely used in industry, in high volume test method, we use this technique, which is photoelectric method, and it's called hygrograph. And there we use the beam of light, normally laser, and we can calculate different parameters. The main parameters we get the span length. So span length has already been discussed in detail during lecture. We get two different varieties of types of span length. We can get 2.5% and 50% span lengths are widely used. In addition to that, we can get any other span length from the graph called hygrogram. Hygrogram is used to calculate many other parameters in addition to the span length. We can calculate mean length and upper half mean length. These are the length related characteristics, and also we can calculate the variability. Variability in hygrograph we measure in two types. One is called uniformity ratio, that is the ratio between 50% span length and 2.5% span length. Another is uniformity index, which is based on the ratio between mean length and upper half mean length. Then another technique was discussed, which is specially for wool fiber, Oira fiber diagram, and then automatic version of this Oira fiber diagram is it's a almeter, which works on capacitance principle. Oira fiber diagram also works on capacitance principle. So I have not received any other question. Okay. I'll request, I'll be available here for next half an hour up to 5 o'clock, say 35 minutes I will be available here. So if you have any doubt, you can ask me question, because you have to appear the online test in this month end, and for any doubt you can clarify. You can send the question to chat mode also. I'll be able to answer now. So I was discussing different aspects of this course. So after fiber length, next important parameters we have discussed was the fiber fineness. So in fiber fineness, the importance of fiber fineness is that to have better uniformity, we need to have higher number of fibers in the cross section. And also for better strength, we need to have higher number of fibers. Suppose for a particular yarn linear density, if we know that fiber fineness, so we can calculate the number of fibers in the cross section. So if you use the finer fiber for same yarn linear density, we will have more and more number of fibers in the yarn cross section. So we will achieve evener yarn, and also at the same time the strength will also be high, because more and more fibers are there, higher contact area will be there, so better utilization of fiber to fiber friction will be there. So for certain strength, if we use the finer fiber, so in that case we don't need to impart higher twist. So we can have yarn with lower twist if we use finer fiber. So in that case we are achieving many positive characteristics in addition to higher productivity in spinning. So if you reduce the twist level, so automatically the productivity of ring spinning machine or spinning machine will increase. In addition to that, with a lower twist, if we have impart, so it will start deflecting, or it will have uniform reflection. So yarn will become little bit lustrous. At the same time, yarn will be softer. So that means if we want to have better fabric feel and better aesthetic appearance, in that case we have to go for finer fiber. There are different methods of measurement of fiber fineness that we have discussed. One was gravimetric method, that is used for cotton fiber. Gravimetric used for wool fiber, that we have discussed. Microscopic method, where we directly get the fineness in terms of diameter. Now, one important thing we have discussed, in textile fiber, most of the textile fiber, we don't use diameter as fineness, because of the fact that the fibers are, most of the fibers are not circular in nature, and that too fiber, the thickness variation is there along the length. So only way to express the fineness is the mass per unit length, and that's true for yarn fineness. So microscopic method is used for those fiber which are circular in nature, and as although wool fiber is natural in nature, but if we take the cross section, it's almost circular. That's why wool fiber we can also express in terms of diameter. Another technique is that airflow method that has been discussed, and here the principle of air drag is being used. So for finer fiber, the specific surface area, which is the total surface area per unit mass. The specific surface area of fiber is high for finer fiber, and the air, when it's flowing through a fiber mass, there will be air drag which is proportional to the surface area. So for finer fiber, the surface area is high, so air drag will be high, so air flow for particular pressure will be low. So using this principle, we can indirectly measure the fiber fineness. So this method is called airflow method. Then optical fiber diameter analysis we can use, which is directly we can measure diameter. Another method is fiber diameter analysis, FDA, which is used by light scattering technique. Here light scattering technique is being used. And another technique, which is vibration method or vibroscope or something. Here we can measure the fineness, mass per unit length of individual fiber. In all other techniques we have discussed are a large number of fibers, but in vibration technique we have to test fibers in single fiber one by one. Okay? Here fibers are being and a particular length being um, under certain tension are being vibrated, and we measure the resonance frequency for that condition, and from there by using a simple formula we can measure the mass per unit length. Then we have discussed maturity of cotton. Here we must remember the term maturity is synonymous of cotton only. We don't use maturity term for any other fibers. Okay? And here cotton grows in different stages, and mainly by measuring maturity we measure the presence of secondary wall. Okay? And we can express the degree of maturity by degree of thickening, theta, maturity ratio, maturity count. So these parameters we have discussed in detail. If you have any question on this parameter, you can ask me now, or you can go through the video courses. And there are different techniques of measurements. Caustic soda and microscopic method, that's by swelling, and the secondary wall will absorb the caustic soda and get swelled, and we can calculate the maturity count or maturity ratio by comparing the thickness of secondary wall with the lumen. Any question? Chetan is asking one question. Can we have your PPT we can do revision at the final exam. So PPTs are available in that during video course, and I think before final exam the transcript may not be ready, but because transcript will be uploaded by IIT Madras centrally, they will upload. But if you follow the course properly, you can go to the particular lecture and you can see the PPT, and portion of PPT you can get in the web link. There is another course that is textile testing. The course was termed as textile testing. The similar PPT you will get for your preparation. You can log in. Again, it's a NPTEL course. NPTEL, the web course. Okay, web course. There, the course title was textile testing. Okay. Okay. Okay, in the forum I can upload the link, so you can see the link. Okay, that we can upload the link. Hope you have got your answer. So we'll upload the link so that you can prepare for the final exam. So you can ask me question, specific question. Okay, thank you, Chetan. So if you have any specific question, you can ask me. So I am here for another say 20-25 minutes, so that I'll be able to answer you. And then maturity we can measure using the Hysteresis method that we have discussed in the in high volume instrument method. We can measure the maturity. In AFIS method we can, and double compression we can measure. Okay? A near infrared method where image processing technique is being used. All these techniques we have discussed in the course. Next is that the two techniques we have discussed: high volume instrument HVI and AFIS. So high volume instrument, so we have discussed, and the AFIS, the advanced fiber information system, that part we have discussed. Okay, and these two techniques are used for measuring the specifically for cotton fiber characteristics, and a large number of characteristics are being tested in this techniques. So in HVI, the difference between HVI and AFIS is basically HVI test the fiber characteristics in bulk, large number of fibers together, but AFIS, it actually separates out the fibers and tests the characteristics one by one, individual fibers. After the fiber testing, we have discussed the moisture in textiles, which is extremely important characteristics. The moisture presence in textile affect many characteristics. So first we have defined the atmospheric condition. The atmospheric condition is defined by three main parameters. One is temperature, and next important parameter is humidity, and then air movement. So if you talk about humidity, there are basically two types of humidities. One is absolute humidity, which is actually the actual quantity of water present in air, and this sometimes it's very difficult to analyze the absolute humidity at different condition, given condition, different temperature condition, different other atmospheric pressure condition. So to compare the humidity, the relative humidity term is mainly used, which is very commonly used. It's nothing but the absolute humidity of the atmosphere. It's a ratio expressed in percentage. Absolute humidity of air and divided by the humidity at saturated condition and expressed in terms of percentage for a given temperature. Then we have discussed the quantity of moisture present in textile material. So they are expressed in terms of two commonly used parameters. One is moisture regain, another is moisture content. And then we have discussed hysteresis effect of moisture. So moisture regain and moisture content, they are how they are related. That also we have discussed. You can solve different types of numericals, and to calculate the correct invoice weight, we can use standard allowable acceptable moisture regain or moisture content. And the effect of moisture hysteresis is that when a material gains moisture and when it releases, the path of gaining moisture and releasing moisture, they are totally different, and this difference is called moisture hysteresis. Measurement of moisture in a textile material is done direct method by oven dry method, and also we can use infrared drying technique. Then we have discussed the various properties, characteristics of fiber on which the fibers which depends on the moisture present. Very common characteristics is that it's a static electricity or even strength. For cotton fiber, the strength increases with the increase in moisture, but for most of the other fibers, moisture absorption reduces the strength. So there are different factors which affect the regain characteristics of material that we have discussed. How to calculate the correct invoice weight? It's extremely important to know the correct invoice weight at the time when we know that we cannot have any textile material without moisture. But at the same time, we cannot supply a material with higher quantity of moisture because the buyer pays only for material, okay, not for the moisture. Okay, and at the same time, buyer cannot say I need material with zero moisture, which is not possible. So there are different standard moisture regain, acceptable moisture regain for different types of fiber, and based on the actual moisture present in the material and allowable moisture regain, if we know this parameter, we can calculate the correct invoice weight, and that is used for measuring the actually for costing purpose. So I have got another question. What is that? Abhishek Chatterjee. Blueprint for the certificate exam. So I think you are talking about your certificate, and after you appear the course and appear the exam, you will be graded depending on the marks obtained. You will be graded at different grade, okay, different standard, and you will be given certificate online by the NPTEL office. So you first appear the course, then automatically you will get the certificate, and this certificate will be extremely important, so useful for your future, for your job, for your career, future career. This certificate you should actually keep safe, and this will be used for your future application. And then we have discussed the linear density of yarn. There are two types of methods: direct method, indirect method, and we have discussed how to convert linear densities of different systems, then how to calculate the linear density of folded yarn. There are different types of measurement techniques we have discussed. After that, yarn twist was discussed. So there are different effects of yarn twist on yarn, and mainly the harshness or the yarn luster, they're directly affected by yarn twist. Then applications of yarn twist that we have discussed, and twist level in a yarn we can express in terms of twist per unit length, typically twist per inch, twist per meter, and another term which is called twist multiplier. Twist multiplier is a parameter which is directly related with the twist angle or the hardness of yarn due to application of twist. We have two different yarns of different counts. If we apply same level of twist by twist per unit length, so their twist angle will be different. You can see the geometry, and accordingly the hardness of the yarn will be different. That we have discussed in the course, during the course in detail. So I can see many of you are watching online. Please ask me any technical question, anything you want to know. Okay. So we have discussed the measurement techniques of Singelian and Pleiadian twist. Then we have discussed the yarn and fabric hairiness. This hairiness, what are the impacts of hairiness? Different causes of hairiness has been discussed. The problems of hairiness we have discussed, and different measurement techniques. So in yarn measurement technique, we have discussed Hartley hairiness tester, Zweigel hairiness tester, and also the light scattering principle, which is used in Zellweger poster. So their detailed principles have been discussed. After that, the yarn irregularity or yarn unevenness. Okay. So yarn irregularity, there are different types of irregularity we have discussed. So how to express the irregularity? So types of irregularities are the random irregularity, periodic irregularity that we have discussed, and we can express the irregularity in terms of percent mean deviation or u%, and another term we can use the CV%. Okay, and we have discussed the limit irregularity and index of irregularity. These are the two terms which actually is useful to assess the performance of spinning machine. So index of irregularity is that irregularity which your present machine, when it's running at its best performance, the minimum irregularity which it produces, it's called limit irregularity. And the ratio between actual irregularity and index of irregularity is called, actual irregularity and the limit irregularity is called index of irregularity. So when index of irregularity is 1, in that case the machine is performing in its best condition. It's a minimum irregularity you are producing. So the machine performance is assessed with the value. Suppose one machine is producing yarn with index of irregularity 1.5, another yarn is 1.2. That means the second machine which is producing index of irregularity as 1.2 is the better than the earlier one which is producing 1.5. Then addition of irregularity and reduction of irregularity that we have discussed. Every machine, it adds to irregularity. How to calculate this we have discussed. Then we have discussed variance length curve, causes and effects of irregularity, classification of variation, random and periodic variation that we have discussed, how to measure the irregularity, and it's related to numericals. Large number of numericals we have discussed here. Then yarn fault classification that we have discussed. After that, tensile testing has been discussed. There are different factors which affect the tensile testing. Tensile strength of fibers. So different terminologies we have discussed. So factors affecting the tensile results we have discussed. Different principles of tensile testing, that is CRT, CRE, CRL, detail we have discussed, and different tensile testing methods of fiber bundle, staple fiber, single fiber, yarn, fabrics. This we have discussed in detail. Then tear strength we have discussed, factors affecting the tear strength, tear testing of fabric, different types of testing, tear testing we have discussed, single rib tear test or tongue tear test we have discussed, double rib tear test, wing rib tear test, element of tear test which measures by the energy method, which is the principle here in Elmendorf is the pendulum river principle. Then bursting strength we have discussed, basic understanding of bursting strength, then the bursting strength of fabric, diaphragm type bursting strength, wall bursting strength we have discussed. Then abrasion and peeling we have, that has been discussed. Basic understanding of peeling, what is peeling? That means the fibers, when it comes out and form small naps on the surface of fabric, it's called peeling. Their mechanism has been discussed, how to measure this bursting, this peeling we have discussed, how to grade. There are different techniques, ICI peeling box, random tumbling peeling test, Martindale abrasion tester, which is used for measuring peeling. So all this have been discussed. And abrasion resistance, factors affecting the abrasion resistance, measurement of abrasion resistance, and Martindale abrasion tester is used, accelerator is being used. Then we have discussed briefly the low stress mechanical characteristics, the bending, shear characteristics, then drape characteristics have been used, and Kawabata evaluation system for fabric, which is known as KESF. This part we have touched upon at very short, because in another course, which is testing of functional and technical textile, there we have discussed in detail the Kawabata system and fabric assurance by simple testing. These two methods have been discussed in a brief. And transmission characteristics we have discussed with also in a brief. So air permeability and liquid transmission, but detailed transmission characteristics have been discussed in another course, this testing of technical and functional and technical textile. So there are different types of moisture transmission. So this is all about the course in brief. So you please see the videos, and I have already sent the link. Link has been sent. Okay, so you can see the link. So I think we can now stop our live chat. So all the best for your exam, and all the best for your future endeavor. And if you have any question, so you can send through the link given in your NPTEL course. So I would love to answer those questions. So till then, Thank you very much. I'll stop the live session here.